As we know, Egypt is surrounded by many constraints that prevent its progress, such as improve the use of alternative energy, pollution, and recycling of wasted energy. First, what is the most significant problem that we focused on in our project? The problem is the wasted heat energy that is produced from several processes and devices which pollute the environment and cause global warming. Second, where is the most popular places that wasted heat energy emits increasingly? Chimneys of factories produce a million amounts of wasted heat energy in the form of smoke per year, especially ceramic factories which produce heat that range from 100 Celsius to 300 Celsius.
After defining the problem, the project specialized in solving the problem by recovering and converting wasted heat energy into electricity by constructing a device depends on Seebeck effect. What is Seebeck effect? Seebeck effect is a theory runs by temperature difference to produce electricity. To illustrate, the device consists of thermoelectric cooler or Peltier to produce electricity when temperature difference occurs. Heat sink, which is surrounded by a fan. It has a large surface area for extra cooling to the cold surface of thermoelectric cooler. Thermal grease, and that to reduce air gaps and also to increase transferring of heat between copper and thermoelectric cooler. Copper sheet, as it has a high thermal conductivity. Finally, converter DC, which transfers the AC current generated to DC current.
To obtain the required design, norms, mechanisms, and techniques were followed, and those are represented in following stages. First, bringing a heatsink, then putting a layer of thermal grease on its base, which has a copper piece. After that, putting a thermoelectric collar above the base of the heatsink, in which the collar side of the thermoelectric collar. Then, placing another layer of thermal grease on the thermoelectric collar on the heat side, and setting the copper sheet that was perforated 2 holes. The copper was connected from 2 holes by a metal wire on the base of the heatsink. Additionally, fixing a fan on the vertical side of the heatsink and steady by a metal wire. Finally, welding the thermoelectric collar and the fan with the input of the converter DC, and the battery with the output by using soldering iron.
After constructing our prototype, we tested it by using a heat source such as benzene flame or candle as shown in this video. Then we concluded the final test plan results, which are: our prototype produced 9.6 volts of electricity and 2764.8 volts per day. The power that produced per 5 minutes is 22.08 watt bulb. The power produced per day is 6,359 watt bulb. And the efficiency is 24.5%. The team members are May Mahmoud, Salma Ahmed, Marina Rafat, and Miral Ahmed. Finally, thanks for your listening and consideration.